Welcome, everybody, to this collaboration between Stanford Medicine's Educational Technology Team and University IT's Technology Training Group as we discuss the future of medical education today. And today's objectives really focus around sharing frameworks and approaches for future planning through the lens of educational technology and in medical education. And we really hope that folks leave this session curious and motivated to apply these tools, and really to your own specific discipline, to medical education, and to life around you. And then to be able to define your preferred future, really think through different approaches for identifying that future, and to be involved in that process and an active participant in achieving your vision for the future. Next slide. So we will be sharing more about our speakers and EdTech. We'd like to hear from the audience today as well. So this is the first of a couple little interactives, and we'd like to ask you in one word, what brings you to this session today? And we have the QR code up there to join polyev.com/Tila. And just take a moment to share a little bit about your interest in the session. See how it's going. All right. Got some folks that are interested in the topic, maybe to be able to connect with the speakers and folks that are joining this session. Love to see curiosity. It's definitely something we like to foster on our team. How do we make it through this very rapidly changing time and thinking about what the future holds for us? Okay. Very good. Yeah, I think a lot of folks are here to learn more about how do we think about the future? How do we apply that, especially within the field of medical education? So just share with you a little bit about the EdTech team briefly. We work across all of Stanford Medicine, and we're part of the Technology and Digital Solutions organization. And our team often engages wherever learning technologies and medical education intersect. So we support classroom activities, multiple MedEd LMSs, and we have instructional designers and media producers that partner with faculty and clinician educators to revise, design, and produce educational content, resources, and online courses. And within our team, we have a group that collaborates across the team and partners with faculty to advance learning innovation and future planning through outreach and engagement and project development. And two of our members of that team, William Bottini and Tila Vessa, will be speaking to you today. One more slide. All right, so just very briefly, thinking about AI as the lens through which we're going to be thinking about future planning. And I'd like to encourage everybody to think back a few years, sort of to the early 2020s, and the affordances, ease of use, and rapid development that were brought about by things like natural language processing and generative AI and things like ChatGPT that certainly had me feeling like I was drinking from a water hose. And where are we now? I think we're still a little bit in the wilderness, sort of something is ending, something new is beginning, and we're at this point of charting out the new thing. And we have sort of a concentrated flow. We have a current, an organized current powering us, but we're also still sort of very much working in our own streams, in our own silos. And sometimes I am not sure where we're going to end up. So I think that is actually a great opportunity to explore and discuss these models and approaches for anticipating and creating our futures. And with that, I will hand it over to my colleague, William.
Thank you so much, Tegan. Yeah, I love that visual of like being lost in the jungle. There was a word in the word bubble, survival. I feel like that one to me is kind of big. Um, yeah, so our team, newly formed team, is the Learning Innovation Futurist team. And that word futurist might sound unique to you or not something you see in a lot of academic institutions, but futurism is a really great lens to look through rapidly changing, uncertain times. It's the practice and field of exploring possible futures to help people make better decisions in the present. So today we're going to explore a little bit about how you might get a grip on the future of medical education using some of the tools of futurism. And we hope that you leave with a couple techniques that you can take back to your workplace, your classroom, or your institution. And we hope that we can keep in touch in the future as well. So, it's impossible to say where we're going. We're not here to predict the future. But it is fair to say that the world we live in is increasingly more volatile, uncertain, complex, and ambiguous than it has been in the last couple decades. This is the term VUCA, which the US Army coined during the Cold War to talk about how decision making in a confusing space is brittle and anxious. So, what can we do about it? To thrive in a VUCA world, we have to adopt some proactive strategies to have vision, create understanding and clarity, and to do so with agility. And so before we continue, let's hand off to Tila for a little interactive about this concept of VUCA.
Okay, so you may have just seen VUCA for your first time. That's okay. Gut reaction, seeing these terms, volatility, uncertainty, complexity, ambiguity, in your current state, or all of the above, in your current state, what's feeling most urgent or scary or top of mind for you right now? We want to know where you're at coming into this space, and then we're going to address how we can maybe tackle some of these big, scary concepts of where we're at. So take a moment. The QR code is also in this top corner if you would like to do this on your phone. Or again, the web URL is polev.com/TELA. We'll give folks a couple of seconds before I show our responses. Love. Seeing some responses coming in so far. Front runner uncertainty, followed by all of the above. I hope we're not stressing anybody out with these terms. We promise we'll give you some strategies to combat some of these feelings that we are all feeling at this point in time. So uncertainty plus all of VUCA, top of mind for folks. Let's get you some strategies for how to deal with this and do some future planning.
Yeah, thank you, Tila, and thanks everyone for sharing. It's really interesting. Uncertainty. I want to unpack that more, but this is where futurism becomes a relevant, helpful tool. So this is a definition of being a futurist that I created that I think is really helpful. So it's about creating outward-facing, deliberate, thoughtful understanding of the patterns and systems that are happening in the world. And that enables us to make strategic, value-driven decisions. So given that, let's talk about a couple futurist techniques that we can use to grapple with the VUCA-ness of the world. And Tila will continue prompting folks along the way for some reflection, and hopefully we'll get to understand what we can do, how we can have some agency, and what everyone else is feeling as well. So to break down some of the strategies we'll apply, I have this little triangle here. Scanning, so following emerging signals in technology, education, and care. Prototyping and running safe to fail pilots. Assessing, preparing for, and understanding new patterns, and stress testing our current strategies against multiple futures. And communicating, distilling your insights to your peers, your colleagues, and leaders. ultimately, we're going to focus on scanning and assessing and some tools that you can use to do those. And then you can take those back to your home base to communicate to all of your people. Ultimately, like I said, it's a method for creating stability and agency. So let's get move into the first tool, scanning. So mapping the landscape. Mapping is a really powerful tool, and my background in graphic design makes me really particularly fond of maps and visualizations. Visualizing can help you spot patterns and gaps and separate things into categories in your mind. These simple 2 by 2 grids are one of the easiest things to make, and now, with AI, you can really have a great time brainstorming what these dimensions should be as you're thinking about how to assess things. Um, so I'll show you a couple maps that I developed. The goal isn't to memorize them; it's just to see how organizing the landscape can help sharpen your own thinking. So this map is a map of trends in medical education. Again, I listed out a bunch of these trends, and then I had ChatGPT help me figure out what axes could be helpful. It was really helpful in organizing my thoughts here. I won't read through everything, but I'll highlight a couple things here. So in the grassroots education quadrant with those red circles, we're seeing learners adopt AI tools on their own quite a bit and without guidance. That's what we call shadow AI. And actually, I put that in purple there because it spans both clinical and medical education. There are some reports that at least 25% of users admit to using unauthorized AI in their workplace or in medical education. Something to keep an eye on. On the institutional side, the AAMC is developing some national AI competencies, a shared framework for what students, residents, and practicing physicians should know about AI. Last year they released a list of competencies for medical educators, and in this spring they're expected to release kind of across the continuum competencies that are suggestions that Stanford and other institutions can apply. Clinical practice, I want to point out, is moving much faster than education. We're seeing a lot of tools integrated into the workflow really rapidly. You've seen Chat EHR that allows you to chat with a bot right in an EHR. Secure GPT, which came out a few years ago, and these walled garden AIs that are safe for patient data, and DAX and other ambient documentation tools. These are really taking a lot of the administrative burden off of clinicians, and there's a lot of demand for that sort of thing. There's a lot of, the takeaway is there's a lot happening in a lot of different spaces. The question is whether we're shaping it or just reacting to it. Let's move on to the next map. This is the second map I made. It's the forces affecting AI adoption. Um, and what's slowing it down? What are the drivers in the near term on the left and the long term on the right? On the accelerator side, learner demand is really high for AI. We're using AI without really understanding what it's doing to us as learners or as teachers or as physicians. And there's real pressure to use these tools, not just intrinsically, but also extrinsically. I want to point out one bubble on here, expectation creep. That's the idea that, well, everyone's using AI, so I should be able to do twice as much work because I have this thing that can help me do it. And on the flip side, there's the idea of AI as a tool to relieve burnout, which is really valuable. On the constraint side, there's legitimate concerns about patient safety, privacy, and the risk of over-reliance. There's a lot of research coming out about the cognitive effects of relying on AI for decision making. Regulatory frameworks are still catching up, but they are emerging, and faculty development takes a lot of time. So there's this tug of war between these drivers these vendors selling AI to everybody, and the slowness and carefulness of regulation. And I think somewhere in the middle of this chart is the right way to navigate this space, somewhere that is safe but able to move fast at the same time. So I created this just by myself. It's not comprehensive, but it's just an example of how you can use mapping as a tool to understand the space of what's going on in medical education.
And with this map, we would like to know which forces on that map popped out at you the most that feel most urgent to you in your current medical education space? Was there something in there, the geopolitics? Was it about the government kind of ordinance? Is there something about new assessment models or this shadow AI that's just been brought up? Which of the topics discussed so far are feeling really urgent and top of mind? And it's that same pull everywhere link as before. You should just be able to type in your response. We got data privacy. Absolutely. Urgent and complex. There's a lot of data. It's everywhere. Trying to figure out what to do with it and who gets access. Liability, absolutely. The threat to higher education, of course. Absolutely. Privacy. A great question in the chat, Pauline. We're thinking mostly in terms of medical education, but I think clinical practice and medical education are closely interwoven. And, whatever affects clinical practice does also need to be incorporated into the medical education space. So my answer is yes. Answer in whatever context makes the most sense. I think it will apply here. Expectation creep, absolutely. Curiosity and hesitancy to adopt, absolutely. Who's in that chart? AI leadership. This is excellent. And I'll make this point again in a bit, but part of the reason we're collecting this data from folks is that our innovation futurist team, one of our goals is to make sure we are reacting to our community's most urgent needs, and we're accommodating exactly what is top of mind and again, what feels most urgent. And so our programming and planning centers around what is this list that you're generating right now. And so a lot of our future work will be informed by what you're sharing today. So thank you again for your participation. This is excellent. And for the sake of time, we're going to keep it rolling. You can keep adding to this list until we get to our next interactive.
All right. Yeah. Thank you so much again. Wow. Like Tila said, we want to learn from you what's most important. And because every single one of those topics could be a whole workshop or a whole semester of exploration together. So let's shift from mapping the present to how do you imagine the future in a way that is productive? Futurists use a method called future casting, which is a forward-looking process to analyze current trends, data, social, technological, and environmental shifts to envision potential future scenarios and how to prepare for them. The further out we look, the wider the range of possibilities becomes. And you could think about these in three categories. The preferred future, what scenarios align with your values or your priorities? The probable future, what happens if things just continue as they are? And wildcards, what are the events that could change everything at in an instant? It's not about predicting the future, but by playing out these scenarios, we can start to identify the signals, the drivers, the things that we need to look out for, and start to work backward toward what can we do right now. So the futures cone is a way that we can visualize the concept of multiple futures. This is one of my favorite charts, and maybe takes a second to figure out, well, what is actually going on here. But we're at this present point, a narrow point, a single slice in time. And as we look into the future, 5 years into the future or so, the cone of what could happen expands in all directions. Anything could happen. And the further into the future we get, the more possibilities there are, the more uncertainty there is. These possible futures that could play out in 2031, they could include things like AI doctors, cures for major diseases generated by AI, more pandemics, universal healthcare, sudden changes in the funding and economic model of healthcare, all sorts of things. And we turn this possibility space into concrete scenarios um, uh, using a couple key concepts that I'll introduce now, and you'll see them in the text on the next couple pages. So drivers are the forces that push us toward particular futures. They're the why might this happen, pressures, incentives, trends. Assumptions are the conditions that we take for granted in a scenario. They're the if this, then that. For example, the amount of federal grants that fund research, it was, I think, for many years, an assumed aspect of the way that academic medical institutions operated. Signals are the indicators that tell us which future we're moving toward. They're the how we know, early evidence that a scenario is becoming reality. Tripwires are the warning signs that we're headed towards something undesirable, red flags. Ultimately, we'll work back from these scenarios that I'll walk through with you using some of these aspects here. So for now, I'm going to walk you through a couple scenarios that I created as a way to think through the future. One is the probable future. This is the default path. What happens if inertia just carries on? Nothing really shocking happens. So if you scan this vision here that I put on the screen, you'll see a couple things. The drivers are maybe sound familiar. Clinical efficiency pressure, AI capabilities are moving faster than we can evaluate them. There's not enough faculty development time, and assessment systems are really slow to change. This, I think, would create a two-speed reality where there's pockets of excellence at leading institutions and piecemeal adoption of new methods elsewhere. This scenario assumes nothing major in terms of regulatory intervention, no trust-damaging incidents, and adoption that's driven by champions rather than a coordinated strategy. The signals that we're headed here, AI champions leading experiments, but innovations stay siloed. So we're not necessarily scaling these great new ideas that we have. And assessment, I think this was another point that someone wrote down in the last interactive. The legitimacy of our assessment methods wobbles and becomes unreliable as we rely on legacy exams that center knowledge, while uh, other others experiment with ideas of assessing thinking or clinical workflows. Tripwires that should concern us, growing gap between the AI-enabled and AI-restricted training environments, near misses that go unreported in terms of possible harm to patients through AI-powered decision making. This isn't a bad future, it's just an uneven one. Maybe it sounds really familiar. Sometimes I feel like even at Stanford, there is an unevenness about the way that innovation and change happens. So innovation exists locally and it's unequally distributed. The next scenario I'll walk through is this wildcard event scenario. So what happens if a rapid development made us change everything in 30 days? Of course, the pandemic is the big example of this. I mean, we literally went from teaching in person to teaching on Zoom in 30 days. It was kind of incredible. Our team was involved in helping train everybody into that transition. Um, and, you know, it was wild, but we really went through it together. So there's a couple kinds, you could think about the capability leap, like everything, uh, a new AI that is a super intelligent AI that changes everything on the planet and so on. But the one I'll focus on here is another one that I think was brought up in the interactive. It's the idea of a trust shock. So an AI related patient harm incident that triggers a regulatory and cultural clampdown. Maybe in maybe an AI is used to care for a patient, and an insurer or legal counsel uh, advises that these tools are no longer usable because of the potential for patient harm. Local oversight and rapid response fails to catch these issues, and the political will to regulate AI is high in this context. Right now, we don't really have that political will to regulate AI. So we don't control wildcards, but we can build adaptive systems that are ready to respond to them. We have these sorts of systems in place when patient harm does happen. So it'd be interesting to try to imagine what could we do to catch and respond to patient harm that happens due to something like an AI technology. So again, this is why local readiness and robust governance matters, even when the default path seems stable. Finally, I'll share my concept of the preferred future, what we'd aim for if we are proactive and strategic. As I share my concept, I'd encourage you to write down a few ideas that you might have about your preferred future. Um, this isn't wishful thinking. It's a future that satisfies our values while respecting our constraints. The vision is governance that moves fast, safely. That is something that the AAMC is directly aiming to do in terms of their AI competencies that they're creating. Um, AI fluent educators at scale. So how can we train our workforce to understand and teach AI to our learners who will need to become AI literate? The drivers that get us there: sustained investment in governance and faculty development, assessment reform that keeps pace, equity by design from the start, leadership treating AI literacy as a core clinical skill. The assumption is that AI is taught as a clinical skill rather than as a separate topic. We have pilots that are evaluating methods before scaling, and institutions coordinating on standards rather than reinventing the wheel in each place. So this doesn't happen by accident. It requires deliberate effort, and I think it's achievable if we're proactive. And I do want to, emphasize again this idea that local leaders like Stanford have a real opportunity here to influence, because other larger bodies are slower to regulate. So that's a snapshot of my preferred future. And now I'll hand it back to Tila to think about this in your context.
Perfect. Thank you, William. And with these listed preferred future bullets, knowing it's not all encompassing, but a good little taste of what we envision would be incorporated into a preferred future of medical education. We're going to ask two questions. First, what you think is going well at your institution. Select just one, or there's none of the above or all of the above, just if you're really feeling confident or not so sure. What do you think is going well? And then we're going to also ask what are we struggling with the most out of this list? Again, to help us inform some of our future programming in terms of what to focus on, but also for you just to wrap your head around, what are the gaps? What are our wins? There's a lot of stuff going on all at once. So where are you at right now, in terms of what's going well at your institution from this list? Governance that moves fast, safely, AI fluent educators at scale, AI literate learners, strategic innovation, assessments that shift towards reasoning or diffusion beyond early adopters. I see some responses rolling in. I'll show the results in about 5 seconds. And please keep voting as we show these results. Do not feel influenced by your peers. It's looking like folks are feeling fairly confident about this diffusion beyond early adopters. Maybe we're getting more comfortable spreading some of these initiatives out beyond just focus groups or individual innovators and leaders. We're seeing this maybe be more widespread. Maybe some movement on AI literate learners, but maybe some folks also feeling like none of the above, some strategic innovation. This is fascinating. All right, in about 3 seconds, I'm going to switch to the next question, which is the exact converse. If everyone's ready, the next question is, what are we struggling with the most? And I would expect a pretty converse response rate here. The same list. What are we struggling with the most? Maybe what we need the most help with right now. Some more guidance, ideas of what to do. We're feeling behind.
Mm.
AI fluent educators at scale. As I guess that governance that moves fast safely was something I didn't see many votes on the last, maybe not any. I imagined that being fairly high. Maybe some innovation, assessment. So I feel like we're feeling pretty comfy that our learners are doing pretty well on the AI literacy front. It's maybe the systems, the governance, and the widespread adoption across our spaces that could use some energy and attention. This question will stay up for the next little while as William closes us out with his last couple of thoughts, and then we'll switch over to Dr. John Kepler to give some insight on what other tools might be useful in this work towards a preferred future.
All right, thank you, Tila, and thanks everybody. So we've mapped the present and imagined some possible futures. Now what? What do we do with any of this? The last step I want to share with you is this concept of backcasting, working backward from the future that we want to identify milestones that get us there. Think of it this way, if the preferred future is your destination, backcasting is the route that you would take and the checkpoints that you need to identify along the way. This is a way for us to identify signals that we're on track or drifting towards something else. So again, this idea of mapping things out is really valuable. This is my attempts to map out with those three scenarios that I shared with you, what would be the signals I would look for along the way from now until 5 years from now. What are the signals that we're going in the right direction, that we're going in the wrong direction? I'll point out just these ones on this upward path here, signals toward the preferred future. I think a couple things that we want to look for and check off are faculty fluency at scale, the idea that responsible AI norms become standard. So right now we don't really have a shared language for what it means to responsibly use AI, and I think that needs to change. Models for learning loops for rapid response when AI-related incidents do happen. So how do we respond if there's, academic integrity issues or something happening in the clinic? And then my hope is that we also get to this idea of assessment rewarding evidence of thinking rather than purely knowledge-based assessment. I think that is one of the areas where AI could be a driver for good in terms of medical education. So given these signals, I think you could start to form some ideas of concrete steps that you could take to get toward your preferred future. If these milestones are metrics or boxes you want to check, what are the things that you need to do to achieve those metrics? That's really the value of this backcasting is it takes this thing that's really big and maybe really far away and decomposes it into little things that you can achieve in, distributed across time alongside your team. So I've thrown a lot at you, maps, scenarios, signals. If it feels overwhelming, I kind of wanted that to be the point. We are in this VUCA landscape, but the response to this doesn't have to be VUCA as well. And it really does seem like local action can influence the trajectory of how AI and medical education integrate. It really, like, even 2 years ago, I remember talking to somebody at Stanford about this idea that you could just say that you want to become the expert in this particular topic in AI and medical education, and with a little bit of work, you can be, because it's such an emergent field. So you don't need to solve everything. Just picking one thing that you can influence is something that you can do. So with that said, we'll wrap up our section with this final question.
All right, folks, before we hand it off to Dr. Kepler and the UIT Tech Training folks to give us some more tools and strategies for your tool belt, we're asking for one thing you can do, one step to apply this new futurist mindset that you have now developed over this last 20 minutes. What can you do to make some steps towards a preferred future? We have a couple of minutes to generate a nice list. We have learn AI skills. Absolutely. There's so much to learn out there, so many resources, so many ways to level up. Yeah, pick an assessment. Let's update it. Let's think about what we're trying to assess in our learners and how we can better have that match the competencies of what we want our future learners to be able to do. Do some mapping, do some studying, ask some questions about how to use AI. Some intentionality on how to engage with AI in your specific practice, but also in all systems. Explore and experiment. This is excellent. I hope that you all are writing this down somewhere else too, so you are making the dedication to taking these steps. And we're going to leave this poll everywhere question open for the rest of the session. Please keep on adding them in for our learning purposes. And with that, I'm going to stop share and hand it over to Dr. John Kepler. Oh, I think you're muted still, Dr. Kepler.
Here we go. Good afternoon, everyone. I am John Kepler, the director of the Stanford UIT's Technology Training Program. And I am delighted to join my colleagues from the School of Medicine this afternoon. I am going to be sort of taking a look at AI in a slightly different way. I'm going to focus on how we should be thinking in this new era of AI. AI is truly a unique technology, and it demands a new way of thinking. I will talk about how this technology really differs from any other technology that humans have encountered in the past. And I will begin by inviting you to just take a close look at this very first slide. You will see a silhouette on the screen. The silhouette is a very familiar image, a human profile. But it's woven together by a glowing, interconnected neural network. This visual really perfectly captures the heart of my discussion this afternoon. AI as a new way of thinking. For decades, our relationship with technology has been somewhat transactional. We gave a computer a command and it followed a script. But we are currently in the middle of a massive mind shift. We're moving away from a world where computers are just incredibly fast but blind calculators that only understand structured data or spreadsheets that we give them. Think of this new world in a new way. Traditional computing is like a train moving very rapidly on a track. It is powerful and it's fast. But if there's even a tiny gap on those rails, a single error, if you will, in a line of code, the whole thing comes to a grinding halt. AI is more like the navigator rather than the locomotive. It has a goal and it has autonomy. It has the ability to adapt its route in real time as it encounters an obstacle. And that is truly remarkable. So in this presentation, we're not just going to look at new features or faster buttons. What we're going to do is explore together how our roles and our thinking should be changing from being the primary generator of work to acting more like an editor-in-chief. We're moving away from a world of rigid programming to a world of an iterative dialogue with technology, or with an AI technology specifically. So by the end of my presentation, I hope that you will no longer view AI as just another tool on your desktop, but rather as a new way of processing the world around you. Let me go on to our next slide, and let me begin by sort of addressing one of the most fundamental shifts that AI technology has delivered, and that is learning versus programming. In all of our previous technologies, a human had to explicitly understand a problem and then write a step-by-step code or instructions to solve it. The machine could only do what it was told. Things are different now. AI has made that really obsolete. You don't need to tell an AI how to play chess by writing if-then statements or rules for every possible move. Instead, you can show the AI millions of different games, basically the data that you train it on, and it infers the rules and the strategies on its own. It has the ability or the capability to learn. It can even discover new strategies that even human masters have never even tried. This is truly remarkable when you think about it. It just is sort of a phenomenal change from what we've had in the past. Now that we're looking at things in a new and different way, we need to sort of peek under the hood and see that the core engine has shifted from explicit programming to machine learning. For the last 60 years or so, if you wanted a computer to do something, all the human had to do is basically write every single line in advance to code the application. And this is what we describe as explicit programming. It's like giving someone a perfectly detailed recipe to follow. Now, today, if you want the AI to come up with its own recipe, it has the ability to do that. In the past, if the recipe was missing an ingredient, the machine would falter. It wouldn't know how to complete the meal. But AI is very different. It can make substitutions. It can come up with new creative options. It truly is remarkable. It operates on this principle of machine learning, which means that it can program itself through observation. It doesn't really need to wait for a human to type out an instruction or a list or an if-then statement. It looks at mountains of data, identifies the patterns, and builds its own internal logic. So to really illustrate this difference, imagine trying to teach a computer to recognize a cat. In the old way, you would have to write some sort of a code to define the shape of the cat, the shape of its ears, the length of its whiskers, and the kind of fur it had and tail, and so on. Today, with AI, you would simply show the AI system as many photos of cats as you can, and it observes the essence of catness on its own. And it learns to recognize a cat, whether the cat is sleeping, jumping, running, or in any kind of an environment. So we're moving away from this idea of rigid logic to what we would describe as probabilistic reasoning. And that is an incredible shift when it comes to sort of how we've worked and interacted with technology in the past. So another key dimension or shift that has really happened, or that this technology has brought, is the fact that it can deal with unstructured data. A traditional database can't tell you if a customer is angry or happy or is complaining about something. AI can look at hidden sentiment and emotions and recognize them in the face of photos or patterns or in analyzing audio and visualize the difference. And this is really remarkable in terms of its ability to deal with unstructured data, something that really in the past, we've never had a technology that had that capability. So that is another key element of this remarkable new technology. An additional difference that I want to highlight between sort of other technologies of the past and AI is how AI sees data. So let's talk about, what happens when AI encounters a particular problem. It is what we describe as reproductive technology. It is very different from it has the ability to be creative force and generate new ideas, things that we didn't have in the past. And that is an incredibly valuable feature with generative AI. For instance, you don't just ask for a snack. You would prompt it and say, I have some leftover tuna in my fridge and some dill and some lemon. What can I make with it? And it will generate ideas. It will give me a recipe. Again, this creative generative ability we have not encountered or had at our disposal in the past. So now let's begin to talk a little bit about the mind shift. What does all of this really mean for us? And what does it mean for our thinking? At this point, you might be thinking, we've had robots in the past, we've had computers doing work for us for decades. What's actually different now? And the answer lies in the shift from automation to autonomy. And that's kind of an interesting distinction. Automation is the old tech, where a machine, again, follows a rigid, predefined track. Autonomy is the ability to make decisions on its own. So AI actually is, once given a goal, is able to adapt and to make decisions based on new conditions or circumstances that are changing. And so imagine, if we had a robot, not just with an arm working with instructions, but now with an AI brain. So its sensors, its vision, and an AI robot brain can see sort of where the car is on the assembly line, adjust its tempo and the motions to meet the car where it is and sort of implement the right type of assembly at the right point. It gets out of a strict pattern. It's able to adapt and accommodate changes as they arise. All of these things really are incredible when it comes to thinking that the technology offers these types of capabilities. So now comes the mind shift. Why do we need a mind shift? Because we have to move away from sort of the rigid technical thinking of how we deal with technology and become more flexible. So I always like to use the analogy of it's the difference between having a map and a compass. The old way was focusing on sort of how we do things, and we have a map. We have to follow where the map leads, and we have to build the map very carefully, and so on. The compass really determines for us the destination, the direction, and the technology can take it from there. Another key thing another key shift in terms of the mind shift is our need as humans to focus on how to solve things and the formulation of problems, how we define problems and sort of submit those problems to the technology to work with it is becoming crucial. And so the ability to really effectively communicate with AI to, of course, understand prompting practices and sort of to give AI the context and so on becomes really paramount in terms of being able to drive the outputs and the best performance from the technology. So there is a key shift here. Instead of focusing on how to do things, we're really now need to focus on our thinking on how do we formulate, how do we redefine and identify problems in new ways and feed this information to the technology to get it to help us find creative and new solutions. So our role is really shifting significantly, shifting from being creators of content to the role of an editor-in-chief. And here, I'm sure all of us have had some point where we were writing something, and we struggled in the beginning. Where do we begin? Where do we start? And sometimes, you hear about, and you see this in movies and so on, an author sitting at their typewriter waiting for a muse, and so on. Now with this technology, let's say I'm stuck and I don't know where to start. I would prompt the technology to tell me, give me 10 openings for this plot, 20 openings. And then as editor-in-chief, that's my new role. I would modify, I would adapt, I would revise, I would ask for some more. I engage with the technology in a dialogue. And this is one of the best ways really to really leverage the benefits of this technology in our work and in education. Another fundamental shift in terms of thinking, in the past, we've been programmed to think, a computer is perfect. If I used a computer to generate answers for me or to correct an exam and so on, because it's following a guided path and a strict formula, it is always going to give me the correct answer. AI, and this is another interesting thing about it, is different. It's not always going to give you the correct answer. I'm sure everyone has heard of hallucinations. So we have to be more skeptical. And this is why, in many ways, in my mind, I really don't think AI will eliminate the need for the human element, because we will always need domain knowledge and the ability to evaluate the output that the AI is giving to us. So we have to be more of a skeptic. We're shifting our thinking, or the mind shift, from the trust we used to have in a computer output, to verification. Now we really need to make sure that what the AI is giving me makes sense. We have to verify resources and validate the output that it's giving to us. So for decades now, we've been trained to be perfectionists when we interact with computers. In the past, if the software wasn't working properly, if you hit the wrong button, something, the machine would freeze and the program would fail and so on. With AI, things are far more flexible. You can't really break the system the way you would break a line of code or hit the wrong button and damage your computer, erase the hard drive, or what have you. There's a lot more tolerance. So now the mind shift is we have to be adaptable. We have to engage in a conversation. It's not about giving strict instructions and expecting an exact output back. It's really about that conversation, the dialogue, the iterative, collaborative process. And this is, again, how we now teach in technology training, how you engage and sort of get the best performance out of this technology through iterative collaboration, if you will, or an ongoing dialogue with the technology. The last item that really I think is also a tremendous mind shift and a new way of thinking when we're dealing with this technology is what I describe as the ability to shift from siloed skills to hybrid capabilities. And what do I mean when I say that? Well, today, if I have access to an AI model, um, I am able to do things that may not necessarily have been within my domain of expertise in the past. So, for example, a marketer can now use a generative AI model to generate a functional Python code, perhaps using Claude, to automate their data analysis. But they're not really a software engineer. The AI did all the heavy lifting. And yet they've gained this capability that they did not have in the past, the ability to generate a Python script or a Python program. And similarly, the software developer who is not a marketer is able to come up with very creative designs and put together a video ad or a magazine spread. This is what I mean by hybrid capabilities. We're now able to do things that before really we did not have the skills or the skill set for it. And so I'm no longer limited by a certain set of skills. I've got flexibility. I can delve into new areas. I can do things that I could not ever do before. All right. And since we are getting to the conclusion of our time, I just want to share with you some of the resources that we also have here at Stanford that are incredible resources in terms of allowing us to engage with this technology. And one of them that is fantastic within the medical educational arena is Clinical Mind. I encourage you all to take a gander at it. It is a platform that allows clinicians to create simulations and scenarios for training purposes. And the AI assumes a patient identity with certain symptoms. And through interacting with the AI in that simulation, it is an incredibly positive learning experience to be able to try to diagnose the situation. So Stanford's Clinical Mind is an excellent tool. We also have the Stanford Playground, which is available to the Stanford staff at no cost, and it makes it accessible for us to try out many of the different models, OpenAI, Anthropic, Meta, and Gemini. They're all available on the platform. Stanford Medicine users are still encouraged to use the Stanford Medicine's secure GPT tool, of course, because of the safety protocols for medical data. And last is perhaps Google's Notebook LM, another great research tool that is also available to everyone on campus. And I encourage you to give it a whirl. It's easy to learn, and it can do some really incredible things. And with that, I will conclude my presentation. I will just conclude by saying, keep an open mind, be willing to explore and discover, and really it is an exciting journey, and there are a lot of incredible things that this technology can do for us. Thank you for listening this afternoon, and I'd like to also express my thanks to all of my colleagues from the School of Medicine, and we will continue to work together to bring you additional training and help you navigate the VUCA challenges of the era. Thank you.
Thanks, everyone. Thanks for joining us. Have a great day.
Thanks, everyone.